Hello everyone, let's start with chapter 12 electricity. So in this we are going to cover 3 questions from page number 209. So question number 1 says, on what factors does the resistance of a conductor depend? So the first factor is the length of a conductor. So R is directly proportional to the length. If you increase L, that is length of the conductor, there will be increase in resistance. If you decrease length, there will be decrease in resistance. So they are directly proportional to each other. The second part is area of cross section. So area of cross section is inversely proportional to resistance of a conductor. So R is inversely proportional to 1 over A. Now if you increase area of cross section, there will be decrease in resistance. If you decrease area of cross section, there will be increase in resistance. So vice versa it is. Now the third part is temperature. Now if we talk about any electric circuit, there will be a change in temperature from the initial part to the final position. So there will be some temperature change. Now if there is a temperature change, that means there will be some resistance change. Now the fourth part, that is nature of material used to make conductor. Now type of material depends a lot, and if there is a change in material, like if we are using silver, made up of silver, or it could be copper, iron or anything, so the resistance going to be varied here. So there are 4 factors on which resistance depend. Now question number 2 says, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Source is same, material is same. The only thing it is dependent on is area. The first one is thick, the second one is thin. So if they have more area, that means their resistance is less. If their resistance is less, then there will be good flow of current. So the right option here is thick wire, because the resistance is less in thick wire as compared to the thin wire. So there will be more current, the current can easily flow here in thick wire. Now question number 3 says, let the resistance of an electric component remains constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? So now we are given with 2 things, that is resistance. Resistance is same. There is a change in potential difference. So we know from Ohm's law, we know that V equals IR. Now from this what we get is I as V over R. Now R is unchanged, V is half, the potential is halved. So it will be V over 2 R. Now the initial one was V over R, and if we change the potential as V over 2, we get that we get is that new current decreases to half of its original value because it is divided by 2. So therefore, according to Ohm's law, we can say that the new current decreases to half of its original value. Now moving on to the next question number 4. So in this it says, why are coils of electric toasters and electric irons made up of an alloy rather than a pure metal? So the first important thing is the alloys actually have better resistivity. Resistivity of alloys are quite high as compared to the pure metal. So therefore we can use coils of electric toasters and electric irons made up of alloy. Now the second one is, if we changes the temperature, like we know that electric toasters and electric irons works on high temperature. So we know that they will get oxidized. So at high temperature alloys, if we are using alloy, they won't get oxidized very readily. Like if you use pure metal, they will get oxidized very easily. So if we are using alloy, that is mixture of metals or non-metals, then they won't get oxidized very easily. So we have 2 arguments against this, that is resistivity, and the second is that they can work quite well at high temperature without getting oxidized. Now question number 5. So in this case you need to use table 12.2. So please open that before you. So the first one, in this it says which among iron and mercury is a better conductor. So we can easily say that iron is a better conductor because its resistivity is actually very least at with respect to mercury. It is very less as compared to mercury. So therefore we can use iron as a better conductor. The second is which material is the best conductor. So out of that table you can see that silver is the best conductor. Why? Because its resistivity is at the least. So therefore this is the answer for question number 5. So thank you for watching this video. Have a great day. Please like, share and subscribe to our channel.